Let us have a look at the stages in the development of a mid-latitude cyclone, also referred to as the process of cyclogenesis. The mid-latitude cyclone goes through a number of stages as it matures and as it travels further eastwards. Remember the acronym IDMOD, where I stands for the initial stage, D development stage, M is known as the mature stage, O for occluded stage, and D for dissipating stage. It is important to remember that certain textbooks might skip certain stages and that others might combine them. Often, the dissipating stage might be left out, and therefore you would only focus on the letters I, D, M, O. Other textbooks would, for example, combine the first two stages and then only speak about the development stage. In that instance, you would then focus on the acronym DMOD, but in all instances, the mature stage and the occluded stage is often the area where the examiners would focus on. The initial stage marks the beginning of the development of this weather system. At the polar front, we have the converging and coming together of warm, moist air from the subtropical region and cold, drier polar air from the polar region. During this stage, the polar front is stationary. We have the two air masses traveling parallel to each other in opposite directions along the polar front. This initial stage also forms part of the conditions that are required for the development of the mid-latitude cyclone. During the development stage, a wave is created in the polar front. This wave results from a disturbance that is caused by the warm and the cold air moving in opposite directions along the polar front. In moving along the polar front, the air creates friction, and that friction results in a disturbance, or what we call a wave, in this polar front. During the development stage, the air pressure along the polar front begins to drop even further, and we have the development of a low pressure cell. At this point, it is important to start paying attention to the fact that the characteristics that are associated with a low pressure cell begin to set themselves in motion. At the place where the low pressure is developed, you're going to start finding that the air starts converging into the center of the low pressure cell, and more importantly, in the southern hemisphere, the air begins to rotate in a clockwise direction around the low pressure cell. The mature stage has a number of characteristics that you need to be familiar with. Firstly, during the mature stage, you are going to find that there is a well-developed low pressure at the center of this weather system. The cold air starts pushing towards where the warm air used to be, and that then creates what is called a cold front. The warmer air from the subtropics starts pushing into the area where the cold air used to be, creating what is called a warm front. These distinct fronts, in other words, the cold front and the warm front, very importantly, splits this weather system into two parts. Each of the parts we call a sector, where all the cold air from the polar region is found in this weather system, that part of the system is called the cold sector. It is called the cold sector specifically because that is where all the cold polar air is found. The warm sector is found in the southern hemisphere towards the northern part of the system, and that warm sector contains all the warm air from the subtropical region. Pay attention to the following, that when there is a cold front, the air behind the cold front is cold, and this explains why, for example, when a cold front passes over Cape Town, the temperature at Cape Town begins to drop and it becomes colder. That is the result of colder air that the cold front is bringing behind it. So please remember, cold front represented by these small triangles has cold air behind the front. Your warm front, which is represented by semicircles, has warmer air behind the front. So to just quickly recap, mature stage, also called the warm sector stage, has a well-developed low pressure at its center. It has a cold front and a warm front, and both fronts are well developed. These fronts split the weather system into what is called a warm sector and a cold sector. The air behind the cold front is cold, and the air behind the warm front is warmer. Lastly, because of the clockwise rotation of the air around the center, please remember that in the warm sector, we say that the winds are northwesterly because they approach any place that is found in the warm sector, the winds would blow from the northwest. In the cold sector behind the cold front, we say that the winds blow from the southwest. So important to remember, in the warm sector, the winds are northwest, and in the cold sector, the winds approach from the southwest. In the southern hemisphere, this process of changing from northwest to southwest is called backing. And this is important that you remember this piece of information, in that you can add to your knowledge on how cold fronts will impact a particular place. The occluded stage is characterized by what we call an occluded front. We can say that an occlusion has occurred. On the synoptic weather map, the occluded front, or an occlusion, is identified by the fact that the cold front and the warm front have merged. If you look at this diagram, you will notice that that section there of the weather system, that is called an occluded front. And on the synoptic weather map, you will find that that part of the front has both symbols for the cold front and the warm front attached to it. So the occluded front on a synoptic weather map has got both triangles and semicircles attached to it. From this point onwards, you will see that there's the rest of the cold front, there's the remainder of the warm front, but this overlapped section closest to the center of the weather system is called an occluded front, or we say that an occlusion has occurred. So what exactly is an occlusion? An occlusion occurs when the cold front starts catching up to a warm front, and that cold front in actual fact starts overtaking the warm front to form an occlusion. And this is possible because the cold front always moves much faster than your warm front. What it in essence means is that your warm sector becomes smaller, but your cold sector starts to increase. At the Earth's surface, it technically means that there is no more warm air in contact with the Earth's surface, and that all the warm air has been squeezed higher up into the atmosphere, and at the Earth's surface, we only experience colder air. So an occlusion occurs when a cold front catches up to and starts overtaking a warm front. We say that the front has occluded, or we say that an occlusion has occurred. On a synoptic weather map, it is represented by the fact that the cold and the warm front have merged, and we have both symbols for the cold front, which is triangle, and the symbol for the warm front, which is a semicircle attached to the front itself. In the dissipating stage, or the final stage, we find that the cold front totally catches up to the warm front. At this stage, we find that the low pressure disappears as the pressure starts rising at the center. Rainfall starts to decrease, and at some stage the rain will stop falling, and all that is experienced is a small gush of wind at this point. To recap, let's have a look at the stages in the development. Remember the acronym IDMOD, I-D-M-O-D, I for initial, D for development, M for mature, O for occluded, D for dissipating. The emphasis is often on the mature stage and the occluded stage. The mature stage, you would identify the mid-latitude cyclone by a well-developed low pressure at the center and clearly defined or distinct cold front and a warm front. In other words, the fronts have not occluded as yet. At this stage, the system is split into what is called a warm sector and a cold sector. The air behind the cold front is cold. The air behind the warm front is warm. In the warm sector, the air is northwest, and in the cold sector, the air is southwest. In the occluded stage, we have the fact that the cold front has caught up to the warm front, and we have the development of an occluded front.